This begins the presentations on the skeletal system. There's skeletal system part 1 and part 2, and then there are also 2 presentations entitled the skeleton, which will follow. What we're looking at here is the function of bone, what bone tissue looks like, remembering what type of tissue it is, and looking at classifications of bones. The skeletal system is composed of bones and the structures that make up the joints. So the tissues are bone, cartilage, and fibrous connective tissue. If you recall, these are all connective tissues. The main functions of the skeletal system are to make a framework to support the body. We'd be a heap of stuff on the floor if our bones didn't give us shape. It also protects internal organs like our rib cage and our hip bone. It contains and protects the red bone marrow, which is called hematopoietic tissue, and this is where your red cells, your white blood cells, and your platelets are made. And the bone is actually the storage site for calcium. We say that we need good calcium intake for strong bones. We do want them to be strong so that they can be a framework and be protective, but we also need strong bones with lots of calcium in them so that they are available for other body functions, such as nerve and muscle functioning and for blood clotting. As we said, bone was a specialized connective tissue, and the thing that all connective tissue had, as you recall, and which you weren't to forget, is matrix and cells. The matrix of bone is made of calcium salts, calcium carbonate, and calcium phosphate. Calcium is taken from the bone into the blood if it's needed, and hopefully it is replaced by our diet. The living cells in bone are called osteocytes. They regulate the amount of calcium that is deposited and when it needs to be removed. Types of bones. There are 2 types, compact and spongy. Compact bone is highly organized, and it's organized in cylinders called osteons. These are like concentric rings of the matrix, and then it has the osteocytes in between it. Another name is the Haversian system. And then there are canals throughout this called Haversian canals, which are the central canal where the blood vessels go through. And then also some other smaller canals called canaliculi. And here again, this is where the cells of the bone, the blood can be brought up to that, and has some other cells in its structure, like perhaps white blood cells for immunity. On the other hand, spongy bone has osteocytes and matrix and blood vessels, but it's a spongy pattern, especially if you look at a natural sponge, but even the manufactured sponge, there's open areas and some sponge here and there. They have cavities of red bone marrow. And this is where, as we said before, hematopoiesis, the formation of red cells and white cells and platelets, takes place. And here we're going to look at the bone structure here a bit. The little circle on the right, microscopic version, you can see those little circular patterns of columns. Those are the osteons, or the Haversian organization. And we can see the main Haversian canal through the center with the blood vessels, and then there are, like I said, little ones that go out, canaliculi, so that blood and what the good things that it brings can go to the bone cell, and it can pick up the waste products of the bone cells. And this is looking at a long bone, which we'll be talking about shortly when we talk about classifications. The long bone has a fat ends called epiphysis, and epiphysis, or epiphyses for plural, and then it has a long shaft in the center, which is called the diaphysis. So we've got long bones, short bones, flat bones, and irregular bones as far as classifying. And it's basically on what they look like, how they're shaped. Long bones are found in the arms, legs, hands, and feet. As we said before, they have a large shaft part, a long, thin, and that's called the diaphysis. That is made of compact bone. The ends that bulge out each end is called an epiphysis, and that is made of spongy bone. And we had said about the spongy bone having the medullary cavity having red marrow for blood cell production. Well, in the adults, these epiphyses are changed to yellow marrow. And in the marrow cavity of the shaft, that is all yellow marrow, which is an adipose tissue. So different from long bones are short bones. We find those in the wrists and ankles. They are made of spongy bone. The flat bones, the ribs, the shoulder blades, the hip, the cranial bones, right? They're not very thick, and those are made of spongy bone as well. And then finally, there are irregular bones, such as the vertebrae and the facial bones. These are made of spongy bone as well. The bones are covered with we had this before when we talked about connective tissue membranes, periosteum. So it's made of fibrous connective tissue. And we said that these collagen fibers coming out of the periosteum come right into tendons and ligaments. And this is really great because here again, tendons connect bones to muscles and ligaments connect bones to bones, and having this a continuous process, that's really good for durability. The periosteum also contains blood vessels so that they can enter the bone and meet up with osteoblasts. There is also articular cartilage on bones that form joints. And that's really good because here again the bones rub and they're moving, and there are some other, which we'll talk about later, structures that help out with this process. But here again, even the fact that they are moving beside each other. And osteoarthritis, one of the problems that happens there is this cartilage wears out. So we don't have that little protective coating. It goes bone onto bone, and so it becomes painful. We'll talk more about bones coming up in the next presentation.